In the last video, we talked about how foundation models learn abilities that nobody programmed. Now the question is, how do we train an AI model on, for example, 18 million heart images without a single label? Well, we don't have enough doctors to do that, and we don't have enough anything to label the entire internet. Now, the answer is so simple that almost sounds like cheating, and the brain already does it. Think about what your brain does every single second. It predicts constantly. If you hear the beginning of a song, you're already predicting the next note. If someone starts a sentence, you already finish it in your head. If you see a ball thrown, you're already projecting the trajectory. And when predicting is wrong, that's when your brain or your model learns. That's your signal. Now, self-supervised learning works in the same way, but a bit more formalized. You take your data, you hide part of it, and you ask the model to predict the missing piece. If the model predicts correctly the missing pieces, then it learns something about the real world. And the nice thing is that it works for everything. Take text, hide part of it. For example, hide the next word. For example, in the case of the Eiffel Tower is located in, if the model learns to predict Paris across billions of sentences, then the model learned geography, it learned language and facts that was never taught about. Take images. You mask random patches and you ask the model to predict the missing patches. Just like in a puzzle, if you have a model that can complete a face even though the eyes are missing, then the model learns how a face looks like. In the case of audio, if you remove a chunk of a song and you ask the model to predict what goes in the gap, if the model predicts well, then it understands rhythm, melody, and structure. So the former changes, text, images, videos, but the principle is the same. You hide, you predict, you learn. What's fascinating is that in the traditional AI, we needed labeled data. So a human will say, this is a cat, this is a dog, this is a tumor in the case of a medical image. And for every single example, this is expensive, slow, and it really doesn't scale well. Now, self-supervised learning flipped all this. So basically, data labels itself. And suddenly you can train on entire internet, on every medical image in every hospital, on every video recorded ever. No labels needed. So this is why foundation models exist. Not because someone invented a new architecture, but because self-supervised learning unlocked all data that was sitting there unused. And that's what we did in EcoJEPA when we trained 18 million heart videos with 0 labels. We masked regions of each video and asked the model, what's missing here? Not the exact pixels, but the meaningful representations. And I'll be talking about those in a further video. So after training, the model could assess cardiac function better than any other method before. It discovered ventricles, valves, wall motion, all on its own. So self-supervised learning. Your data is the teacher. Hide, predict, learn. And it's one of the most important ideas in modern AI, and most people do not know. And is the reason why your phone, your search engine, your ChatGPT work the way they work very, very well. I'm Theodora, AI in 60 Seconds. Subscribe for more.